So, good morning, dear students. Myself, Dr. Ligraju, Assistant Professor, Government Patel Degree College, Tumkur, in Department of Physics. So, last previous we discussed sounds, resonance, Fourier transforms, equations, so all these things. So in these concepts, so we have to discuss some important problems. So it is 5 marks questions. So here we can also solve around 7 to 8 number of problems. So and also I will give some problems also, so you can just solve it using a same what I have already given the theory concepts along with the formulas. So using the concepts, so you can solve it. So first we'll discuss first problem number 1. Here you see, just first here we have to understand the problem. If we know the basic theory concept of the particular subject, so we can easily understand the problem. Of knowing the problem concept, so what are the things here we require to find out, and what are the things they are given? Knowing all these things, we are going to calculate. Now here we come to the first problem. Calculate the minimum intensity of audibility sound for a note for frequency around 1000 Hz if the amplitude of the vibration is 10 to the power of minus 11 meter. This is the problem. Here they are given some assumptions. Assuming the density of the air, it is already we know it, given value, that is 1.293 kg per meter cube. And also sound is we know it, that is 340 meter per second. So this is the given problem. So here they are given intensity, that is 1000 Hz. So amplitude, the density. So here we have to do that, and also it is given a velocity. So knowing all these things, here we have to calculate the minimum intensity. So the problem of this formula of this problem is I is equal to 2 pi square f square a square rho v. 2 into pi, constant values, into f, frequency, a, amplitude, rho, density, v, velocities. Here they are given f value, you see. They are given rho value, they are given a value, and velocity. So here all these values are given. We have to substitute all these values to find out the minimum intensity, that is I. I is equal to 2 into pi, that is the value of constant 3.14 to the power of square into 1000 Hertz into square into, so A amplitude, this is given 10 to the power of minus 11 to the power of 2 into next rho, that is the density of the air, is given 1.293 into v, velocity of the sound 340. Of knowing all these things, just using a scientific calculator, calculate all these values, we are getting a answer, that is the minimum intensity I is equal to 8.7 e to the power of minus 13 watts per meter square. So it is a direct problem. So we can easily calculate. Using if you know the problem formulas. So next here we come to the second problem. Minimum intensity of audibility of sound of 10 to the power of minus 12 watt per meter square. If the frequency of the note is 1400 hertz. First up, find the amplitude of the air particles if the density of air is 1.293 kg per meter cube. Here they are given air data. Air is 1.293 kg per meter cube. So that is the density they are given. Velocity of the sound, that is also 340 meter per second. So in this velocity, the sound will be travel in air. The density of the air is this way given. High. See here it is given. The previous problem we have to calculate. Here it is given. I is equal to 10 to the power of minus 12 watts per meter square. Frequency 1400 hertz. Density 1.293 kg per meter cube. So V is equal to 340 meter per second. We have to calculate here A, that is amplitude. As like previous problem. Here we have a formula. In this formula, we have to make it simplification of these equations towards A, that is amplitude. So A you have to take in left hand side, then remaining all these things right in right hand side. A square is equal to I by 2 pi square f square rho v. Substitute all the values. I given value 10 to the power of minus 12 divided by 2 into pi constant value, that is 3.14 to the power of 2 into f means frequency, that is 1400 square into, so rho is also given, that is the density of the air 1.293 into 340 velocity. So after calculating all these things using a scientific calculator, so directly in one step we are getting the answer, that is equal to 0.767 into the power of minus 11 meter. It is the amplitude of a given variations. So you see, last previous two problems, they are given directly. You can easily calculate it, find out the values. So such a type of problems are also given in the examinations. So you can having some difficulty to get a complete marks in a theory, but in the problems you can get it 100% marks if you know proper understanding, if you understand properly the problem, because all the problems are very simple, direct concepts. So if you know the concepts, you can easily solve it. Next here we come to the third one. The intensity of sound is 5 into 10 to the power of 12 watts per meter square. The frequency is 100 hertz. Calculate the amplitude of sound in air at STP. Also calculate the amplitude of sound wave when the temperature of air is 30 degrees Celsius. Velocity of sound at STP in air is 332 meter per second, and the density of the air is 129 kg per meter cube. So here what here we have to calculate, what the values here they are given. First we have to understand in the problem, write the given data, then what is the required formula. So think it, guess it and write it. If you know the formula, knowing the problem, you can easily calculate all these things. Here you see, they are given data, that is density of an air. velocity of the sound of the wave, that is 32. Then T, temperature 30 degrees Celsius. Frequency 1000 Hertz. Same thing as the above said previous problem. Amplitude A, we have to calculate. I is given 5 into the power of minus 12 watts per meter square. Next. So, of knowing the intensity equations, make it simplification of these equations towards the amplitude. A square is equal to I by 2 pi square F square rho V. Simplifying of all these things in the square, then we are getting A is equal to these values. So, you see, in the previous formula, so we calculated as a square, we are calculating the values after that taking the root of these values. But here, initially, we are going to take the root. A is equal to these values. So, now we are getting amplitude. A is equal to 7.7 into the power of minus 8 meter. So, after calculating all these data, substituting in the formulas, we are getting A is equal to 7.7 into the power of minus 8 meter. And next, we have to calculate if STP, amplitude of the sound wave at STP is given. Next, if it is at the 30 degrees, what is the value of amplitude? If it is a constant or varies, we have to calculate, because here the two steps they are asking. You see, so calculate the amplitude of sound air at STP and also calculate if it is at the 30 degrees. Second step we are going to calculate at 30 degrees, that is A is equal to square root of 1 I by 2 pi square F square rho of V. A is equal to square root of, substitute the values, I, that is 5 into the power of minus 15 divided by 2 into pi square. Pi means constant value. The value is 3.14 square into F, frequency 1000 square into rho into V, that is 3.49 into V. So that value is 349.8. Okay, the rho value is missing here. Rho value is how much? That is equal to 1.293. Just we have to substitute here. 1.293. Rho is missed. So you write it here. Then calculate, that is A is equal to 7.49 into the power of minus 8 meter. Of knowing the amplitude from this one, just you compare it. If it is at the STP, what is the value of this A, amplitude? If it is at the 30 degrees Celsius, what is the value of the amplitude? So the amplitude will be going to decreases in terms of around 0.1 or 0.2, that's all. So that is the value of the amplitude of this frequency of a sound waves. Next here we come to the fourth problem. See, it is a Fourier transformation related formula related problem. The sound wave intensity is of 3 into the power of 6 watts per meter square and 5 into the power of minus 9 watts per meter square. Express the differences in intensity in decibels. Other value here we are going to explain in a decibel arrangements. So now here, how to calculate all these things? They are given. We have to express the differences. If the wave intensity is this value and the wave intensity is this value, so what is the differences of intensities? We have to calculate it. Here we know the formula, that is d delta L, delta I of L, delta high means intensity, delta high means increment value, difference value. So here we have to go to calculate delta I value, delta I of L, that is equal to, the formula is log base 10 of I1 by I0 minus log base 10 of I2 by I0. So here we know we have to simplify these equations towards log base 10 of I1 by minus of log 10 base 10 of I0. Similarly, you take the minus of denominator. So minus of log 10 of I2 plus of log 10 of I2. So next here these two will be going to cancel. That is I0 and I0. The remaining thing is delta L is equal to log of 10 I1 minus log of 10 I2. So delta L is equal to log 10 of L1 by L2 bell. So we are going to express the sounds or intensities are in a bell form. So it is also one kind of a unit. When the difference in intensity level is expressed for D in dB, we get delta L. Delta I is equal to 10 log of L1 by L2 of dB. So now here given data, I1 is equal to N is 300 minus 6, I2 is equal to 500 minus 9. Substitute all these two values. Simple, very simple. If you know the formulas, you see how we can easily calculate it. Because the problem is itself in the physics. If you know the well-known knowledge about the particular formulas, you can easily calculate, you can easily explain the way and also calculate the values. Here only the subtractions. Very simple subtraction is there. So knowing that the formula related to a particular problem, we can easily calculate. See, you divide these two values, we are getting a 400. So difference of intensity of L is equal to 10 log of 400. So substitute once again simplification, log of 400, that is equal to 26.02 dB. So it is the differences of a sound wave intensities if they are having these intensity values. This intensity values the difference of intensities in decibels is this values. So like that here we are going to explain. Next is fifth problem. In this fifth problem, so how we are going to explain the thing, just observe it. A ball of volume 6000 meter cube is found to have a reverberations time of 2.5 seconds. The sound absorbing surface of the ball has an area around 7000 meters square. 7000 meters square. Calculate the absorption coefficient. The ball having a volume 6000 meter cube. That is the values given. Reverberation of 2.5 seconds. The sound absorbing surface of the hull has an area 7000 meters square. Calculate the absorption coefficient. We know, in theory we discussed it already. The reverberations time is given T is equal to 0.158 V by A alpha. So now here absorption coefficient is given, that is alpha. Alpha is equal to 0.158 V by A T. T equal to alpha. Here because you have to calculate alpha absorption coefficient. That is equal to 0.0158 into, so V. V is given now, that is how much? Volume 6000 divided by, so area, that is 700 into time 2.5. If you calculate all these things, we are getting a 0.542. You see how much very simple. It is 5 marks problem. And also these are all question paper problems. Very simple and easy way to solve. So far, don't neglect, especially problems. You concentrate on problems. At the time of examination, these problems will be improves, boosts your marks. Just you can see after your examination in your marks in the marks card how your marks will be going to boost if you are attending a proper way of all the problems. You are attending all the problems. Next is sixth problem. So find the acoustic intensity level at distance of 8 meter from a source that radiates energy at the rate of 5 watts. Consider reference intensity as 100 watts per meter square. Here they are given acoustic intensity level at a difference of 8 meter from the source, that radiates energy at the rate of 5 watts. Consider the reference intensity as 100 watts per meter square. We know that the intensity is given by I is equal to power by area. This formula is a POC level problem. We know it, the intensity is equal to power. It is a 5 divided by area. It is a acoustic for level. No, so far we are going to take as a 4 by R square. So substitute R also given. So what is the value of R? That is a 64. Okay. So we have to calculate it here. So 5 power divided by 4 into 3.14 into so 8. 8 square, that is equal to 64. Next is I. Direct values here you can calculate it. I value is given. Of knowing I 6.22 meter watt per meter square. Now here we have to calculate second part. Acoustic intensity. So here we have to calculate the value of N. Okay. So radiates energy. Consider reference intensities. That N is equal to 10 log of I by I naught. N is equal to 10 of log base 10. High value is how much? That is equal to 0.00622 divided by 100. So we are going to write directly, it is in the form of, so now kilometer per pound, millimeter per pound, it is becomes to 0.006 millimeter, 622 divided by 100. Calculating these two values, we are getting a N is equal to minus 42.6 dB, 42.6 dBs. So it is about sixth problem. Next, here we are going to discuss seventh problem. You see, a cinema has a volume of 7,500 meter cube. It is required to have a reverberations time of 1.5 seconds. What should be total absorption in the hall? It is very interesting problem. See, the cinema hall has a volume of 7,500 meter cube. It is required to have a reverberation time is 1.5 seconds. What should be the total absorption in the hall? What is the given values where V given volume 7,500 meter cube, then T plus 1.5 D ticks. So reverberation is 1.5 seconds. Okay, so we have to calculate the value of T is equal to 0.165 V by sigma of AS. Sigma of AS is equal to, we have to calculate these values. Okay, so what should be the total absorptions? Sigma of AF is equal to 0.165 V by T. Substitute the values. 0.165 into V, 7,500 by T, that is equal to 1.5. T is equal to, that is, if you calculate all these things, we are getting a 828. 828 is the answers. So next is last problem, that is the eighth problem. So this is The volume of a room is 1200 meter cube. The wall area of the room is 220 meters square. The floor area is 120 meters square. The average sound absorption coefficient for wall is 0.03. For ceiling is 0.08. For the floor is 0.06. So everything is given. Calculate the average sound absorption coefficient and reverberations. Time the average sound absorption coefficient. Reverberations. A average is equal to A1S1 plus A2S2 plus S3S3 by S1 plus S2 plus S3. A average is equal to A1, that is 0.03. ಯಾವುದಕ್ಕೆ wall 0.03 for a wall. Then into 220. Next is ceiling 0.08 into 120. Here the area. Next is 0.006 for floor into 120. Here. So calculating divided by 220 plus 120 plus 120. So if you calculate all these things, you are getting a E average is equal to 0.24. Then the total area of the room is S is equal to S1 plus S2 plus S3. S is equal to 220 plus S1, 120 for S2 plus 120 for S3, that is equal to 460 meters square. The total absorption in the room is A average into S, that is equal to 0.24 into 460, that is equal to 110.4 BCNs. Next, after knowing this one, here we have to calculate reverberations time, that is T is equal to 0.165 V by average. The value is, the concept of this one is total absorptions. Total absorptions. Yes. Total absorptions. T reverberations time is equal to 0.165 V by total absorption, that is sigma is equal to S. T is equal to 0.165 into 1200 divided by sigma of S, that is given, that is 110.40. It is given in the formulas. It is a standard values, it is given. Standard values is given, that is 110.4. So from substitution of all these things, we are getting a T, that is equal to 1.8 second. 1.8 second. So like that, here we are going to solve all these problems. For correcting of all these problems, just I gone through the so many different kinds of a reference books. There is a Sundarajan. It is around 2011 published through a college physics, and also Subramaniam around 2012 using the textbook of optics. So Mangalagauri around 2018, they under the graduate of physics. So like that, and there's two more Nagakrishna, handbook of physics, Krishna fundamentals of physics. Using all these things, so I correct it. So thank you. Next class we discuss one more other new chapters. Thank you.